So I welcome you for the second session of Quantitative Research Methods course. And before I start anything else, I would like to give some more discussion. I would like to share some more points about your assessment. First of all, there'll be assessment on the final day. And on that day, there'll be three components of assessment. The first one would be your review of literature presentation, which is individual task, which means that each one of you would pick up a research article and first of all, the research articles are available in Optima in the research article folder. But what you need to do is once you book your article that, okay, fine, this belongs to me, so that nobody else takes. You can't, not more than one person can present the same article. So it has to be separate, okay? So you make a choice, you reserve your article, and then start discussion in the discussion forum that this is my article, so nobody else takes. And the one who starts this discussion first, I request others to follow the same thread. So don't send me 13 different titles of messages. So keep the same message title, just follow the thread. Make sense? All right, that's one thing. Now this is selection of the article. What you will be doing, you'll be getting around 10 minutes each of you. And what you are supposed to do during this presentation is that don't spend ages about discussion of the research problem and the objective. Say it clear, simple, fast. And then spend most of your energy on the following things. You can write down if you want, but it remains recorded. Your first main focus of attention, focus of discussion should be hypothesis building. Number one. Number two, discussion about data, the nature of data, the type of data, and the main variables, and most importantly, how the data has been collected, what has been the sources of data, and how the variables have been formed based on this data. The next thing you'll be doing is which kind of analysis has been done. Is it descriptive and inferential? Which models have been used? Okay. And then what are the major findings of the article? So, and then when you are discussing about the main findings of the article, you will not just say what article, you can't just reproduce things from the article. You need to show in slides the output of a research article and show that, have a discussion that this coefficient shows that correlation between age of husband and age of wife is positive and significant. So explain the whole output in your own words. Okay, and if at all, I'll be very pleased, if at all, you can find the limitations of the methodology, that even though the researchers have done great job, this is the variable, perhaps they should have taken variable separately, not this way. Maybe this is not a very good indicator of variable. So you can also criticize. All right. Why this point is very important, that if I say, if my objective of a topic, of a research topic is to check how intelligent are my quantitative research students. And the variable of measurement I'm using is who is more present, who comes to the class more regularly. All right. Then, well, why I chose this variable, because to me it seems that the theory says that those who attend the class are supposed to be more sincere And those who are sincere are supposed to be intelligent. So I can build up some kind of theoretical arguments. Okay? But the critics can say, the naysayers, the devil's advocate can say that no, this is not a good measure of intelligence, because people can just come and be on Facebook. People can just come, listen, and go. What is the guarantee that they are listening to you? Perhaps researchers should have organized some presentation, or the researcher should have organized some exam. Now, exam presentation is also measures of intelligence. You get my point? So there are some phenomena. The phenomena can be measured differently. And if you have some major disagreement with the author, you don't have to disagree with them for the sake of it. But if you find some concrete reason to disagree with the authors, why not? By the way, they are not the damning gods. They also commit mistakes. They also have some problems. Okay. So sometimes they just have a data limitation and they take some suboptimal variable. They use it as a measure. You can criticize it. Or the article is only focusing on descriptive statistics, but not inferential statistics. In that case, you can be loud and say that, no, here we disagree with authors. So, quick recap, what you are required to do in the review of literature task. Don't spend hours and hours on objectives, these things. Have a title, first of all, title of the article, the authors, write your name also at the bottom. Give the title of the article. You can even take a screenshot of the paper, the article, and put it there. So that it's very clear that which article you have chosen. So you don't have to type time and again. Say it in a few words, the main objectives of the article, okay? Then go to your hypothesis, type of data, nature of data, source of data, how the variables are formed, all right? Is it descriptive or inferential statistics technique used? Which are the main statistical tools which the articles have used, which model they have used, and then you make the presentation of findings. I would say findings, you need to produce the main tables of output. Once again, don't shy away from taking the screenshot of those outputs. So you don't have to, because some tables are very big. You can't do it. You can, but it will take you weeks and weeks. Don't do that. Take a screenshot, explain in your own words. And this thing, I will not leave you alone. I will do it by myself. So I would give you a dummy presentation by myself, how to make a presentation of research article-based theme, all right? And then finally, if you are able to find some limitations of the research article, please share. There we go. The second part of your assessment would be, a research plan, or rather proposal. Proposal is the shorter version of plan. First you propose something, then you plan something. Okay? The research proposal would be based on the assumption that you are doing some quantitative research by yourself. Some of you may be doing it, but some of you are not doing it. Some of you are not doing any research at all. All right. In that case, you can assume what if phenomena. What if I'm doing research? So what if I'm doing research? What I will do then? It's based on a hypothetical situation that what if you have to do, not have to do, what if you choose to do quantitative research, then you take some hypothetical theme. Again, what the thing will remain same, that these will be my objectives, but focus more on methodology. If I have to do some research on quantitative techniques, then these would be my data sources, These would be my variables. All right. This is how I shall model. How would you learn which model you will have? Well, there are articles available. Okay. At least one article will definitely impress you that this model, this database, this technique, this is the way to form the variables. I shall like to do it. So this is based on completely, how to say it? What is it? What is it called? What is it called? This is like a simulated. It's a simulated situation that when you assume something and start behaving accordingly. So you'll be assuming that you are going to do some quantitative research. And then all the components, all the contents of quantitative research, you will be explaining. But once again, remember, because your theme idea will be dummy, will be fictitious, so don't spend ages, once again, on exploring research objectives. Focus more on methodology. And as I said before, what is included in the methodology? Some discussion about hypothesis. Okay. Number two, the discussion about the data, which data you take, why you take, where this data come from, okay? What are the data sources? What are the limitations of data? Sample size, by the way, I forgot to say before, sample size, how many firms, how many interviews you will do. Then comes your, how you make your main variables, all right? Variables are very important. I told before that if I want to measure how intelligent you are, and I choose wrong measure of variable, then my research would be of low quality. I have to justify which variables I choose. If I want to see how much social amenities, facilities are available in Uvascula, I can take many measures. I can take how many doctors per thousand of population are in Uvascula, how much distance you have to travel from your home to go to hospital, how many roads density is in Uvascula. I will also see how many crimes have been committed last year in Uvascula. So what are all these indicators mean? And I can also see how many schools, how many day centers are in Uvascula. How far a child has to travel, walk before he or she reaches school. Shorter the distance, I assume higher the welfare. So these are called variables. Question is, you can't take all these variables. If a topic is how the welfare in Uvascula has changed for the last 5 years, you can't take all these variables. Rather, you must not take all these variables. The question is then which variables you take, which measures you take, which indicators you take. But you can't choose just randomly. You have to give justification. When you choose something, you also have to give a reasoning. Why didn't you choose something else? Are you with me? So not only you give justification that I choose X. The second paragraph, you have to give a justification why you did not choose Y. This is research, this is reasoning. When you are researching, you are like a lawyer who is making a court case. So you have to prepare all the statements. All right. You also have to prepare statements which the opponent lawyer will ask you, so that you don't start thinking, oh, what to say. So you not only prepare your own arguments, but you also have to estimate the arguments of your opponents. So this is it sounds a bit complex, but once you start familiarizing yourself with the research articles, take some sample article. First of all, have your legend article as soon as possible. Today, one thing I expect from you, that you go through the list of articles in Optima and reserve your article. Okay, but be quick, have a look. It's like a shopping, but be careful while shopping the articles. And if you can arrange your own article, why not? But first of all, you have to get it approved by us. And how to get it approved? Send the details of the article attachment in Optima discussion forum and send it to us, or email to me, and then we can approve it if it is okay. If it doesn't fit in our parameters, we'll say that no, I don't think you should choose some other article. Make sense? And the third thing is your exam, the old-fashioned pen and paper-based exam, and that will be a closed book exam for sure. And I guess you will be having 1 hour. You will get 3 questions. You attempt any 2. So you will have a choice not to attempt one. The one you know the least, don't try. And if you try all 3, then the answer with the least marks will be ignored. So you will get the best 2 answers that will be graded. All right. So this is how normally if I'm sorry. Yeah. The next topic, which I want to discuss with you, is kurtosis. Kurtosis, sorry, skewness, I should do first here. Skewness. The skewness shows that how symmetric the data is. Sorry, you have a question? The skewness is, I think we did last week, didn't we? Skewness we did here. All right, let's forget it. The skewness is that how scattered the data is. The next thing is kurtosis. Kurtosis is that how pointy the data is. Sometime you plot the data. Look, in the ideal situation, in the very ideal situation, I would like to have a data like this. Perfectly, normally distributed, very symmetric. But sometimes it happens. It's like this. The red line, the red curve. Do you know what you will call this red-tailed, red graph, red curve data curve? What will you call it? Which one? Blue or red? Blue is normal distribution because if you see, it's very symmetric. So the one point on the left side is equally distant from the same point on the right side. Very symmetric. All right. I would say that if I give you data right now, 1, 2, 3, 4, 5, 6, 7, 8, 9, and if you plot it, believe me, it would be symmetric because mean will come exactly in the middle. The average will come exactly in the middle. Yeah. If I say 1 to 9, yeah, the middle will be 5, I guess. If you have the number from 1 to 9, the middle will be 5. Will it be 5, 6, 7, 8? Yeah. So in that case, this is 5. So 1, 6, 1 point is the right 6, 1 point is the right 2 points is the right 7, 2 points is the right 6. All right. But if you look at this red curve, mean, mode is here, mean is here, and they are scattered. Okay. This is called skewness. The real life example of skewness I can give you. Take a country, and based on per capita income, can you say that there is a country in the world where the per capita income is evenly distributed? We often say that 5% rich in this world own 80% of assets of the whole world, do you think if I plot people and their wealth on a graph, the curve would look like blue curve, normal distribution curve? No. The curve would be asymmetric, scattered. So it will be either left-tailed. You see what? Left-tailed, which means that most of the people in the world are below average. Which means that we have maximum of poor people. Or it will be on the right-tailed. If you are in some locality and you want to find the prices of the house, you buy the houses, yeah? Let's say there are 30 houses. It could be possible that all the houses have the same price or very symmetric. If you plot them, it's very symmetric. But it could be also possible that there are 2 or 3 houses which are super expensive, but the others are not so expensive. Or it could be possible that some houses are super cheap, but the others are very expensive. So in that case, your data would be asymmetric. So when, for example, in the real life, this is not a technique for the sake of fun. This technique we use when we do some kind of macroeconomic research, especially the income distribution, how well people are having access to facilities. For example, the research topic is, imagine, all right, we have lots of good social facilities in Uvascula. The question could be, the research topic could be, do all the people living in Uvascula have equal access to the public health services? It could be possible that in some parts, the access is very good, but there would be some parts where access may not be so good. So in that case, your curve would most likely look like left-tailed, or it could also be like this. When you plot these curves, they could be asymmetric. This is called skewness. Okay? Then come the topic kurtosis. Kurtosis is that when you plot the data, how pointy it is. You can see that. Let's say one curve is this. So what do you observe between this, not this figure, but that figure? When you compare the red graph and the blue graph, what do you observe? What do you observe? You know, there are 2 geographical shapes. One is called mountain or a peak, and the second is called plateau. The plateau is like the surface is very high above the sea level, but when you go on top, it becomes flat. That's called plateau. And the mountain is mountain. You know, it's like the base is, it's like a triangle, you know. So so who's more pointy, mountain or a plateau? Mountain. That curve, which looks more like a mountain shaped, has higher kurtosis. Okay, so you can see here, this curve is very pointy, yeah. Okay. And if you plot this curve, and it looks like this, it's more flat. So this curve is called positive kurtosis. It's called lipokurtic, and this is called negative kurtosis or platokurtic. So look at the name itself says it's platokurtic and this is leptokurtic. The question is, what is the utility of ketosis? In my last example, when I said that people in this country or people in some country, their income is not evenly distributed. Okay, so there is unevenness in the society, but that's measured by skewness. What is the extent of unevenness? How rich, very rich are, how poor, very poor are. This is measured by ketosis. If there are gaps between rich and poor, but those gaps are not so substantial, then your curve should look like this. So first of all, not everybody the income is evenly distributed. There are gaps between rich and poor. All right, but the gaps between rich and poor are not unbearable. But in the other case, the gaps between rich and poor are really, really, really substantial. So then the curve becomes more pointy. Okay, so this is the usefulness. So with the skewness, we come to know how scattered, how asymmetric the data is, and to what extent this asymmetry exists, how far there's a gap, how far there is unevenness, that we check with ketosis. Remember, you don't have to remember any formula to calculate it because the SPSS is so, it's such a smart system that it calculates by itself. Okay, that's ketosis. So these are some shapes. Then the other things that we use, am I recording? Yeah. So the other things that we use is called the measures of dispersion that we use very often. Dispersion is scatterness, how scattered the data is. Dispersion shows how scattered, how fragmented, how, I would say to some extent, can you really rely on your data? Is your data consistent? Imagine I organize an exam and you all appear and the average score is very high. The next day I organize another exam with you, all of you present again. And exam questions are not the nature of the exam question is not so different from the yesterday's exam. But today, the average marks drop. So I organize your exam after every day, after every second day, same students, same type of questions. And at the end of the day, what happens is that on one day, your exams are, your average marks are very high. On the other day, they drop. Can I say confidently that I trust your intelligence or your knowledge? Can I say with confidence? So because when I organize an exam, it's like organizing or conducting an experiment. So I'm conducting an experiment on daily basis, and you are my respondents. But the finding which I get from you are changing very erratically. So there is no, I can't really consistently trust your intelligence. Because one day you can be remarkable, but on the second day, you may not be doing so well. If this is a situation, then I would say in statistical terms, the data's dispersion is very high. But on the other hand, I conduct an experiment today, yesterday, tomorrow, day after, and so on and so forth. And the findings are very much, if not exactly the same, they're quite similar. They are corresponding to one another. There is a difference, but the difference is not so substantial. So then I can say that you have less dispersion. Hence, I can rely the data and the findings based on it. I can really rely on it. So you are more consistent. I want to give you one more example before we go further. The three clubs here, Chelsea, Manchester United, and AC Milan. Each of them play 4 matches. May I ask you, what is their average goal score per match for each team? 3. Can I say that their average performance is 3? Now I move from goals to performance. I would use the word performance. 3, performance. Can I say that these 3 football clubs have same performance level? No? But you said their average goal is 3. What is goal measuring? Goal measuring what? Now we are slightly sidetracked, but in a nice way. What is your variable? What is the variable of performance of a football team? How less they sleep? How far they travel to play a football match? How handsome the players are? How nicely uniform? Is it the measure of performance? The proof of the pudding is in eating. Football club play football. In football, you win by scoring. Hence, the score, the goal are the measure of performance. So in this case, the variable is performance. How do you measure it? Through goals scored. You get my point? Goal score. Goals are the measures of the performance of the football team. My next question to you, is this performance, are they, let me put it this way, is the performance of each of the 3 clubs equally reliable? Is the performance of each club equally reliable? Have a look at the data. Reliable, you can believe. Can you? Chelsea, it scores 2 goals, 3 goals, 3 goals, 4 goals. Before Chelsea enters the football pitch, the average goal is 3 for each. Yeah? Remember, this is the way you write average. X bar is before this Chelsea enters the football pitch, were you very sure that they will score 3 goals? And remember, I'm only taking 4 matches. If I took the data of last 40 matches, then look at the Manchester United. Their performance is so erratic. I mean, one day they score 3 goals, which is enough to get a draw. And on the second day, they can score 8 goals. Goodness me, they can completely butcher their opponents. On one day, third day, they score 1 goal and nothing. So the graph of goals going middle level, high level, bottom level, and nothing. Look at AC Milan. 3, 3, 3, 3, 3. Which of this data is more consistent? Which team is more reliable? AC Milan. Even though the performance level of each club is same, because they are scoring same average goal, but the reliability of the performance may not be the same. Dispersion measures exactly the reliability of the measure. How scattered the data is. Not reliability of the measure, but the reliability of the data. is data reliable? Like in the another example, I told you that I organize exam every day, same students, same course, same teacher, same nature of questions, but the performance varies. Right? It means that the data is scattered, I will not say inconsistent, I would say non-consistent. All right. This is a little bit about dispersion, but I will explain a little bit more about it subsequently. But the scatterness is more. The scatterness is more if the data is located on more distant points from the line of equal distribution. Closer the bond between the points, stronger the bond between the points, lesser is the dispersion. And larger the bond, the larger is their spread, more spread means lesser reliability, hence more dispersion. All right. So when you take some sample in which you are interviewing people and you interview 50 people, I give you simple example for the consumer behavior. Your topic is that how much people buy, what is the people's behavior, attitude towards online shopping. So if people are making advertisement on Facebook, how you respond, and you are taking 50 respondents. All right. And most of the respondents are on the extreme side. So let's say half of them say 5 on a scale of 0 to 5. Yes, we love it. And let's say half of them say, no, we don't like it. We hate it. This is not a good way of shopping. So the points are very extreme. Responses are very extreme. In this case, I would say that your data is having more dispersion. And imagine there are 50 people and everybody is giving a score 3, 3, 3, 3, 3, 3, 3. Imaginary. It will not happen, but just imagine. And even though there is some variation, it's not far away. It's not far away from the line of equal distribution. All right. In that case, your data has no dispersion, less dispersion, or high reliability. Make sense? Yeah. Anything you want to ask me before I go next? Yes. No, it's different. It's different. The line of equal distribution is like a trend line. So imagine you plot the points. So let's say you ask 5 questions to people. The questions 1, 2, 3, 4, 5. And here on the y-axis, I take the response. These are responses. Okay. For a given question, the response don't vary too much. So if I draw a line, fictitious, imaginary, hypothetical line, you can see that some people are on top of the line, some are bottom, below the line, but the top and below are not substantial. But if I do another topic of research, I take the same question but different respondents, and the views are for each question. In this case, again, I draw a line of equal distribution which will be same. But in this case, the range, look at the word range. The range of responses will be much widespread. So one measure of this dispersion is called range. And range is what? The gap between the maximum and the minimum number. In case of Chelsea, the range is 2, isn't? Because the highest goal or maximum goal or maximum minus minimum, yeah? The maximum goal is 2. Should I say 2 or 2 goals? When you say range, when I want you to calculate a range of Chelsea, these are goals, by the way. So one lesson we learned when you have the tables, always write down the unit of measurement. Because otherwise, people can say Chelsea 2 what? 2 million spending on the fees of the players or what? So you have to specify what this 2 is. So the measure of the variable, the team, the measure is goal. Okay? So in this case, the range of Chelsea is 2. What is the range of Manchester United? What is that? 8. Because highest is 8 and lowest is 0. 8 or 8 goals? 8 goals. And what about AC Milan? 0. 0 goal. All right. Range. Then we call coefficient of range. Coefficient of range. What could be the possible difference between range and coefficient of range? Do we have coefficient of range out of fun? Range is okay, maximum minus minimum. What about the coefficient of range? Coefficient, remember we have 2 types of measures in life. One is absolute measure and the second is a relative measure. Relative or comparative measures. When I say that this man is 6 feet tall and the second man is 5 feet tall, I can say that the taller man is taller by 1 foot. This is the absolute measure. But when I say the taller man is 1.2 times the shorter man, then I will not say 1.2 foot or feet. I would say times. So when we calculate the ratio, then the measure becomes comparative or relative measure. The reason we have we have the range or the coefficient of range is there's something called there's a saying which says size effect. Size matters. We want to neutralize this size effect, and to do this we use the comparative measures or the relative measures. All right. When you calculate range, your answer will be in the same unit in which the question is given. But when you calculate the range coefficient or coefficient of range, your answer would be unit less, unit free. It will be a ratio. All right? Because that neutralizes the size effect. Otherwise, the big companies, the big organization would have the higher values. All right. Which could be the good example for you. Okay. I'm not convinced yet with myself with the range and coefficient of range yet. I have to find some more examples for you. Okay. After I give you this example, I would give you a break. Yeah. Is it okay? Write down the data on a piece of paper and write it in the column wise. So the first value, the first thing you, first column title is Microsoft share price. Microsoft, you know Microsoft? Microsoft share price. And the second column, you write down Nokia share price. You know Nokia? Anybody who doesn't? Okay. For Microsoft column, write down the first value, $1,000. $1,000. And the second value you write for the same Microsoft column is 1,100. 1,100. So Microsoft has two values, $1,000, $1,100. 1,100, yeah? For Nokia, you write down for Nokia, because I have to keep the same unit, so let's write in dollars, yeah? For Nokia, you write $20, $20. Sorry? So Microsoft is 1,000. And Nokia is 20 and 40. And you are observing as a student of business, even though you don't study very hardcore finance, but when you see these two values in Bloomberg, in Forbes, in any data, what do you make out? Which company is more successful? Which company is performing better? Yeah. So did you say Microsoft? Microsoft, Nokia? I want to have some more opinions. So we have a 1-1 vote, 1 vote each for. The question is, which company is performing better? The reason I chose this example, because I want to give you the example of, or I want to explain more about absolute measures and the coefficients or the relative measures. Any more opinions? Which company is doing better? Which company do you think is performing too well? Microsoft or Nokia? The point of view is absolute measure of performance and relative measure of performance. When you see the absolute measure of performance, then definitely you can say, oh yes, Microsoft, their share price is so high. You sell one share, you get $1,100. But when you see the comparative, so see what the question is given in dollars, yeah? The unit is dollar. And if you say that Microsoft is better because their share is selling for $1,100, hence it's better. When you make such a decision, I'm not saying this way of calculation is good or bad. When you make a decision based on the absolute unit, and you are in this category, then this measure of performance or measure of assessment is absolute measure. But when one can argue that, hey, this is not a good comparison because Microsoft is much older, much bigger than Nokia. It has presence in almost every country in the world. The size is big. Look at the size of Microsoft and Nokia, no comparison. But when you see when you take away this size effect, when you treat a very big wrestler and a slim wrestler together, if there's a wrestling bout between somebody in 100 kilo weight and 60 kilo weight, it's not a comparison. You can't say that the wrestler with 100 kilo weight is better than the one with 60 because the absolute size is different. If you make some kind of new kind of competition where the size effect is neutralized, then we are in the comparative measure or the relative measure. But when you see the relative performance, I would say Nokia is better. How? Because yesterday, Nokia's price was 20. Today is 40. There's a 2-time increase. Whereas, see, did I say $2 increase? I said 2 times increase. So I'm not taking the unit of analysis here. But when you compare Microsoft, is a 1.1 times increase. So who performed better? Nokia. In absolute or relative performance? Relative performance. So this is why in the quantitative research, when you are taking a sample of, like for example, my students, they take sample of hundreds of companies. All right. Obviously, the companies which are big have more profit. Doesn't mean they're better than the small companies. No. Then we find the ratios. Return on assets. So what happened? Profit divided by assets. So what happened? The size effect is neutralized. Why a company is big? It has more assets. But when assets become as a denominator, they all become one. All right, you get my point? So when you want to take away the size effect, then we are talking about the comparative measures. Make sense? Sound sense? But you know what?